is there an elegant way to solve for the shady area? Okay, let's take a look. So first we have a right triangle. Here's the right angle. And we know that this side right here is 2, and this side right here is 4, and this and that are equal. The goal is to find the area of this red square. How do we approach this? Well, of course, to find the area of a square, we need to know each side. If this is x, then of course the area is just x squared. But I'm not actually going to call this x, because what I'm going to do is, if you look at this, if we connect the diagonals, so if you draw the diagonal from here to here, and let's do this diagonal as well. Because this is a square, we know that the diagonals will be equal, and also this is going to be 90 degrees. Moreover, this will be equal to that. And in fact, because this is 90, that's also 90, this is equal to that, this is equal to that, you can argue this and that will also be 90 degrees as well. Now, have a look. What do we see? Here we have actually a triangle, and then we also have a big one. We'll be using similar triangles. So, I'm actually going to draw down the big triangle, the smaller version for it right here. So we have this one right here. I'm looking at the big one, so the whole thing is 2, and this right here is 4. And what I'm going to do is, I'm going to call this x. So that's also going to be x. And this is also going to be x, so this right here is going to be 2x. So the smaller one right here, right, the blue one, that's 2x. And then I'm just going to go from here to here, like this. And this triangle will be similar to that. But what's this length though? Okay, the whole thing is 4. This and that are the same, so this right here will be x as well. So the blue part is just 4 minus that x. So we have that. And this is also 90 degrees. Now we can just set out a proportion, depends on how you want to do it. I can do this side over that side, which is 4 over 2. That will be equal to this over that, 4 minus x over 2x. And perhaps I'll put this little thing right here to show, because they are similar triangles. Oh, by the way, I should also have mentioned, because they're just similar. Let me see, how can I give a reason. 90 degrees and okay, do I really have to say something that they are similar? Well, this is just obvious. It's pretty... Another thing I had to mention is that because this is 90, that's also 90, so this side and that side are parallel. Yeah, so you can also argue that this angle and that angle are the same. So for sure, it's clear that they are similar, because angle. I think that's a pretty legitimate reason already. Okay, and now let's just look at this equation and then solve it. So I'm just going to do here. That's the same as just 2. That's equal to 4 minus x over 2x. And let's just multiply both sides by 2x. So that 2x times 2 is 4x. And this times that will just be gone, and we have 4 minus x. And we can add x to both sides. And we get 5x equals 4. Divide both sides by 5. So x is equal to 4 over 5. Good, but we still haven't answered the question yet, because we're trying to find the area of the square. How can we use x and the side? Here's the deal. Because the diagonals right here are just, this part of the diagonal is x, and this is also x. And that will be 45 degrees. That will also be 45 degrees, 90 degrees. So the ratios are 1 square root of 2. So if this is x, that's also x. This right here will be x times square root of 2. Therefore, the area of the red square, which is this shady area here, you just take this side, which is x times square root of 2, and you square that, which is of course just 2x squared. And of course, we have 2. X is equal to 4 over 5, so we can just put that down here and then square that. Okay, do the exponents first. 4 squared is 16 over 5 squared is 25. Then we just do 2 times 16, which is 32, and over 25. So the area of the red square is just 32 over 25 unit square. Yeah, that's it.